Hello, welcome everyone. We'll get started in just 30 seconds or so and give people a chance to enter. But thank you so much for being here. I'm looking forward to talking about how to go solar with you today. Welcome everyone. We're going to go ahead and get started, and maybe some people will join us while we're going through some of the intro slides. My name's Abby. I'm a program manager at Solar Oregon, and today I'm going to be going through some information on how you can get solar ready, go solar, and also exploring home energy storage. Without further ado, let's get started. So first up is the agenda for this evening's presentation. First, I'll be going through how solar works and how you can know if your home is right for solar. I will then dive into the exciting topic of home energy storage before discussing the various incentives that can help you to pay for both solar and storage technologies. I'll then talk about how you can get started with solar. So first up, a little bit about the organization I work for and myself. I work for Solar Oregon. Solar Oregon is an education, outreach, and community advocacy organization that focuses on educating people on how they can go solar and supporting solar power in general. We are not a solar installer. We are not trying to sell you anything. Our goal is to just educate people so that they can take control of their energy future and get solar. As I go through a few more intro slides, I'm also going to start some polls just so we can know who's in the room for us. All of these are completely anonymous, but you are welcome to skip any poll that you are not interested in answering. Solar Oregon is a member-based organization. You can donate today or become a member on our website, solaroregon.org, or by scanning the QR code that's currently on the screen. You can also follow our social media and Eventbrite at Solar Oregon to find out about any great events we have coming up. Just giving it a few more seconds on this poll before I'll close it out. And then also move on to the next slide at the same time. Okay, I'm going to go ahead and launch the next poll. This one is shorter. Speaking of great events we have coming up, one of our annual events, the Go Zero Tour, is October 5th. So 1 month from, is today the 5th? 1 month from tomorrow. This is an open house style tour of homes throughout Portland that have solar power and other exciting energy saving technologies. Tickets are on sale now, and currently they are early bird tickets, so you can save some money if you buy your ticket. That event is on our Eventbrite, so go there if you're interested. And last poll I'm going to launch before the presentation. Another great event we have coming up is our Green Energy Series. This is a monthly webinar series run by some of our great volunteers and board members that focuses, and this month we'll be focusing on resiliency through placemaking. So be sure to check that out on Saturday if you're interested. And thank you so much for going through those polls. This presentation is also made possible by support from the Energy Trust of Oregon. Energy Trust of Oregon is an independent nonprofit that works to provide access to affordable energy across Oregon. Thank you so much, Energy Trust of Oregon, for your support. Throughout the presentation, if you have any questions, please feel free to put them in the Q&A button at the bottom of your screen. I'll be going through all those questions at the end of the presentation, so there's no need to wait until the end to ask your question. Feel free to put it in whenever you think of it. If you have a question, someone else in the room probably does as well, so please don't hesitate to put it in. And now, without further ado, I'm going to dive into the main part of the presentation, starting with how solar works. So here's a diagram of a simple solar system. On the far left, we have the photovoltaic or PV panel. This is what would be mounted on the ground or on the roof of your home, and when sunlight hits it, it will generate a volt of electricity. From there, that electricity will flow into an inverter or microinverter, which we'll be talking about in more detail in just a moment, which converts the electricity from DC or direct current electricity that is generated by the PV panel to usable or AC electricity that is usable by your home. From there, it will flow into your home electric panel and into anything in your home that runs on power. This includes all your lights, your kitchen, charging your electric vehicle, or just anything that we use power for. If at any point in time your PV panels are generating more power than your home is using, the excess power will flow out to the utility meter and out onto the utility grid to be used by your neighbors. This is what we call a grid-tied solar system, as it is still attached to the grid, as opposed to an off-grid system where you are fully disconnected from the grid. This utility meter does also flow in both directions, so if at any point you are generating less power than your home needs, such as at night when the sun is down, you will be able to draw power from the grid in order to power your home. I'll be talking about all these things in more detail throughout the presentation, but that's the basic system, and as you can see, it's quite simple, which is really nice. And that also makes it highly modular for your specific needs. So first up, I'm going to talk more about inverters and microinverters. An inverter pictured on the left or a microinverter pictured on the right are both great pieces of technology that, as I said, convert the electricity generated by your solar panels to usable electricity for your home. They do this by converting the current of electricity from DC electricity to AC electricity. Both inverters and microinverters are great options, and they just really depend on what the needs of your system are. An inverter takes in all the electricity from all your solar panels and converts it all at once. First, and will usually be paired with a second device called an optimizer in order to minimize the amount of electricity that is lost in transit. In comparison, microinverters, you will have microinverters mounted on the back side of your solar panels, similar to what is posted here. Those little black boxes are microinverters, and those convert the electricity from only 1 to 2 solar panels at a time. So if in your solar panel array you have, say, 10 solar panels, you could have up to 10 microinverters. Both are great options that are installed frequently throughout Oregon, and as I said, it really just depends on the needs of your system and is a great discussion to talk through with your solar contractor in order to see why they suggest one versus the other for your home. The next step is mounting. So mounting refers to how your solar panels are attached to whatever they are attached to. Most common in highly populated and densely populated areas are roof-mounted solar, pictured on the left. This is when your solar is mounted on your roof. This is particularly popular in places like Portland, where we don't quite have the space for the other option, which is ground-mounted solar panels, which are solar panels mounted in the ground. You can see an example of this anytime you drive out through the Columbia Gorge. There's some great solar farms that you get to spot from the highway. Ground-mounted solar is a great option if you have the space. However, it can also have some added costs from needing to build the structure for the solar panels to be mounted on and run conduit from the solar panels that could be farther away back to your electric panel. It really just depends on what your needs and considerations are. Another option is solar roof tiles. This is solar that is your roof. So rather than having your solar mounted on top of your roof, this is a product that is both a solar panel and a roofing product. There are several brands available. However, it is much newer tech and therefore much more expensive. If you're interested in solar roof tiles, definitely make sure your contractor has installed them before and is familiar with the process so that your home is protected from the elements. Next, I'm going to talk about net metering. Net metering is the process that allows solar to help you save money by tracking the amount of electricity you are exporting and importing from the utility grid. So to explain this process, I'm going to go through 2 examples, first of a typical sunny summer month and then of a more cloudy winter month. So starting with the sunny summer month, if we think back, or just this week, it's going to be 90 degrees. It's going to be nice and sunny. We still have pretty long days. If you had solar, they would be generating a ton of power right now. It's still sunny. There's no clouds. They're doing great. And overall, in the summer months, you produce more solar power than you need, the blue bar. And that excess power that you are then exporting to the grid is earning you net metering credits as signaled by the green area here, showing the difference between your solar produced and the amount you are consuming from the grid. So you are building up net metering credits all summer long. Now, if we think like 6 months from now, it's going to be cold, the days are going to be short, it might even be snowing, or it might have just had an ice storm that is cloudy and gray, and we're all a little bit grumpy about it because we're ready for some sun. That's when your the amount of power your solar panels are producing is going to be a bit lower, as pictured on the right in that orange bar. You're still producing some power. Even on a cloudy day, your solar panels will produce some amount of power. However, it is not enough to meet the amount of power you need to run your home. Therefore, you will then use the net metering credits you built up during the summer during the winter in order to offset the consumption, the amount of power you're having to draw from the grid. Net metering credits roll over from month to month, which is what allows this to work. However, they do not roll over from year to year. So the net metering year begins and ends on March 31st and April 1st. So any credits you have left over on March 31st are unfortunately forfeited. This is why sizing your system to be the correct size is very important. So now to look at what this looks like a little bit in practice, here's an example energy bill. On this bill, we can see the net meter reading at the beginning of the month at 237 kilowatt hours, and the reading at the end of the month, 564. That means that this customer generated an extra 327 kilowatt hours for this month, which gets added to their year-to-date banked excess generation bank here on the bottom of 3,072 kilowatt hours, and their billable kilowatt hours for the month are 0. However, if we look in the box on the right, we can see that their bill is not 0 despite the 0 billable kilowatt hours. This is because despite having no billable hours, just being attached to the power grid you pay a certain amount of money in order to cover taxes and fees in that interconnection. Here in Portland, that fees usually between $12 and $20, and why it's unfortunate you will not have a bill of 0. That is much less than the average Oregon electricity bill of about $70, and it is not going up at nearly a high frequency. So that is how net metering works. Please put any questions you have about it in the Q&A. As I said at the beginning of the presentation, I'm happy to talk about it in more detail. So as I said, because net metering credits roll over from month to month, but not year to year, it is very important to size your system correctly. Your system should be sized based on how much electricity you consume. You want your system to meet and not exceed your expected usage. Your system size will be measured in kilowatts or kW, and the average system size in Oregon is about 8 kilowatts. Now, with all this information on how solar works, how can you know if solar is the right fit for your home? So first, really quick, to dispel a common misconception, no matter where you are in the state, in general, Oregon receives enough solar resource to make solar worthwhile. Here we have a diagram that shows the sun at both the highest point in the sky at the summer solstice and the lowest point, the winter solstice, and we can see that is always in the southernmost part of the sky. This means that solar panels are most beneficial if they can be installed on a south-facing roof plane. However, they can still be worthwhile if you only have east and west. However, they usually cannot be installed on north, northeast, or northwest facing roof planes. Now, one thing that can limit your ability to get solar panels is if your home is very well shaded. Any shade will obviously limit the amount of solar resource your panels are getting and can make getting solar not worthwhile. If you do have some shade that prevents you from getting solar, don't despair. I would just recommend looking into community solar instead. But those trees are also helping decrease the temperature of your home and in general are very, very good. Next up is roof complexity. So here we have an example of both a complex roof on the left and a much more simple roof on the right. In the complex roof, while they have lots of south-facing roof planes, they are all much smaller, and any solar array would have to be chopped up into many smaller arrays rather than one large continuous array. This can lead to added costs from making the arrays smaller and lead to added complications. In comparison, the simple roof plane will allow for one continuous array. In addition to the structure, the design of your roof, what is actually on your roof matters. We recommend that you have at least 20 years of roof life left. This is because solar must be taken off when re-roofing your home, and this can add an extra $5,000 to $10,000 in your re-roofing costs and can frequently lead to some solar panels getting damaged. If you are expecting to re-roof in the next 2 years, we recommend holding off on getting solar until you've already redone the roof of your home. What's on top of your roof matters just as much as what's underneath your roof. So solar panels that are roof mounted will also require you to have the necessary supports to support the extra weight of the solar panels. If you have trusses, like pictured here on the left, your roof can support solar panels in even the most strictest permit areas of the state. However, if you just have rafters, like pictured on the right, you might need to complete some extra engineering to either prove that your rafters are stable enough to support the solar panels, or to even add some trusses to your roof in order to make sure it can support it. So now, with all those details about solar power out of the way, I'm now going to dive into the exciting topic of energy storage. So, energy storage makes solar more efficient. This is because on its own, solar does not allow you to use power when the grid is down. The ability to use power when the grid is down is known as energy resilience, and when the grid is down, your solar panels have to be shut down and not be trying to export or generate any power that could be going to the grid in order to protect any workers who are currently trying to fix it. This means in order to retain power while the grid is down, you would need to have a battery. This is just a quick example of what that can look like. So here we have a battery on the left and solar on the roof. Now, why would you be interested in energy resilience? As I said, energy resilience is the ability to use power when the grid is down. There's lots of reasons the grid can go down. One of which, short frequent shutoffs can be caused by storms or squirrels, and there also can be public safety power shutoffs, the first of which occurred in Oregon in 2020 in order to lower the fire risk. Your power could also be shut off if they're doing some needed maintenance on the line. I know I recently got a notice about that in my neighborhood. And your power can also be lost in the event of the Cascadia seismic hazard, which is a specific risk we have here in Oregon, which is expected to cut off power in the Willamette Valley for up to 3 weeks and much longer in other parts of the state. When it comes to picking a battery, there are many brands and chemistries available. However, installers may specialize in one specific battery. This means that if you know you want battery A, you want to make sure your contractor knows how to install that battery and has worked with it before. An important thing to also remember is that there is no mixing and matching. If you already have battery A, you will not be able to add battery B onto your system. You would have to continue and get a second battery A or replace battery A with a battery B as well. Your battery can be a different brand from your solar panels, though. When it comes to a battery, lots of people want to back up their whole home. However, this can be prohibitively expensive to do for any significant length of time. Because of that, most people instead elect for a partial backup. A partial backup is when you create an essential loads panel where you physically move some breakers from your main electric panel to a secondary one, and only that secondary panel would retain power in the event of an outage. This does add complexity and cost that can allow you to pick and choose what you want to retain power and what would no longer function if your home is out, and can help your battery last longer in an outage. When it comes to thinking about what would be moved to essential power, it's a question of what needs power and for how long. The more things drawing power from the battery will lead to your battery lasting less time. There is the potential for your battery to be recharged if your solar panels are getting some sun. However, if it is quite cloudy or rainy, that can not happen and you can be at a loss. Typically, people choose to back up a fridge, a few lights in common areas, and maybe an outlet or two. Next, a question we commonly get is when to install storage. There's two types of storage, both AC coupled storage and DC coupled storage. This just refers to where in your solar system it's installed, whether that is before the inverter or after the inverter process. You will save money if you install solar and storage at the same time. However, storage can be added to an existing solar system at an extra cost. Another thing to remember is that batteries require space. Ideally, they can be placed near your electric panel in order to save on the cost of wires and conduit. However, they can be installed in other places, such as outside or in a garage. However, they cannot be inside a crawl space or cupboard, and they must meet the National Electric Code. Now, with all the great technology I've talked about, I'm going to start going through some incentives you can receive to help pay for them. If you have, again, any questions from the previous slides, feel free to stick them in the Q&A. So the first incentive I'm going to talk about is the Solar Investment Tax Credit, or ITC. This is a 30% of the total cost of your system as a dollar-for-dollar tax credit. Now, really quick, before I talk about this more, I am not a tax professional. Really wish I was. Probably be able to save a little bit more money on my taxes if that was the case. However, I am not, and this is not official tax advice. Please consult a tax professional with any in-depth questions or about your specific situation. So as I said, this is a 30% dollar for dollar incentive that can be applied to both solar and storage. In order to claim this incentive, you do need to have tax liability, as it just decreases your amount of taxes owed by 30% of your total system cost. If you do not have enough tax liability for the full 30% in 1 year, it can be claimed over several years. There are a lot of common misconceptions on the internet about what can be claimed under this tax incentive. The most common one we hear about is people claiming that re-roofing costs can be claimed. However, this is not true. So again, please consult your tax professionals and be aware of any scams that are out there. The next incentive that I'm going to be talking about is the Energy Trust of Oregon Solar and Storage Incentive. So Energy Trust of Oregon offers $1,000 for PGE and $1,200 for PAC Power customers for installing solar power, and $500 per kilowatt hour up to $6,000 maximum per home for energy storage. In order to access these incentives, the only thing you as a consumer have to do is work with an Energy Trust of Oregon trade ally, which I'm going to be talking about more later. But they will apply for these incentives on your contractor, who, if they're an Energy Trust of Oregon trade ally, will apply for these incentives on your behalf, and it requires no extra work on your part. You just get to save the money, which is great. Another great Energy Trust of Oregon program is the Solar Within Reach. This is their income qualified program that can just save you a little bit more money. So just ups those standard incentives I mentioned earlier by a little bit more. Similarly, you do have to work with an Energy Trust of Oregon trade ally contractor, and for this one, you also have to meet a certain income threshold. However, the income threshold is very generous, with a household of 4 income threshold being $128,564. So please check it out. Even if you are not low income, you may still qualify for this incentive. Now I'm going to be going through some budgets in just a moment, but really quick, I'm just going to go over reasons cost can vary when it comes to solar. These are going to be example budgets of what it could look like for an average system. However, solar systems are highly modular, and what I show you today might not be exactly what your budget looks like. Similarly, costs can vary a lot with storage, and the same holds true for the budgets I'm going to go through that includes storage. So first up, for an 8 kilowatt solar system, the cost before incentives is $32,000. And from there, you can then claim the Energy Trust of Oregon incentive to the full amount, depending on your utility and whether or not you're income qualified, bringing the out-of-pocket cost to you, the customer, to $30,800 if you're a PAC Power customer, $31,000 for a PGE customer, or $26,000 for PAC Power customers if you qualify for Solar Within Reach, or $24,800 if you qualify for Solar Within Reach within PGE. From there, you can then claim the 30% federal tax credit to reduce the cost by another 30%, making the final cost to you, the customer, before energy savings, $21,560, or just around $17,500 if you're income qualified. Next up, we have if you are adding a storage, if you're adding storage after you've already previously installed solar, this makes the cost of your solar is that same $32,000. However, the cost of the battery being added after you've already installed solar is $23,000. You do receive the full incentives that I previously talked about, and making the out-of-pocket cost to you, the customer, about $48,000. And if you're income qualified, that out-of-pocket cost is between $39,000 and $34,800, depending on your utility. From there, you then do get to claim the 30% federal tax credit, making the final cost to the customer before energy savings about $33,500, or between $27,300 and $24,360 if you are income qualified. Lastly, we have an example budget if you are installing solar and storage at the same time. So this is for an 8 kilowatt solar system, a 13.5 kilowatt hour storage system. The cost for this entire system before incentives is $52,000. You then get to claim those energy trust incentives, and the out-of-pocket cost to the customer is about $45,000. If you're income qualified, the cost is around $33,000, depending on your utility. And from there, you can then claim the 30% federal tax credit, making the final cost to the customer before energy savings about $31,500, or if you're income qualified, about $23,000. So those are some really big numbers, and it's very common to use financing for them. There are some loan options that are tailored specifically for solar, and your installer may even have a financing partner that they prefer to work with. However, as with any major financial decision, be sure to talk to a professional and make sure you are reading through all the documents very carefully. You can also ask your bank if they offer any loans tailored to solar or your local credit union. So now with all this information, how do you get started? In order to access those Energy Trust of Oregon incentives, you have to work with an Energy Trust of Oregon trade ally, and thankfully we here at Solar Oregon really like the Trade Ally program. Trade Ally is a certification that Energy Trust of Oregon provides to contractors. It indicates that they are rigorously qualified and are approved to offer all Energy Trust of Oregon incentives, and therefore are familiar with all Energy Trust design and installation requirements. I'm going to stick right now in the chat a whole bunch of links. Included in these links is the link to the Energy Trust of Oregon Solar Bid Tool. Using this tool, which is now linked in the chat, you can request a custom analysis and bid from solar contractors that work in your area. The tool will allow you to put in your information and will then send your information to up to 3 contractors that work within your area for you to receive quotes for. Once you receive a quote and select a contractor, it is then on to installation. Your contractor will complete all paperwork except for the tax credit, and depending on where in the state you're located, permitting can take from 2 to 12 months. Here in Portland, I think it's between 6 and 10 months at the moment. However, other parts of the state, it can be just a few weeks. Once you have all the permits needed, your installation will be very quick, usually only 1 to 4 days, and your contractor will manage all inspections and interconnections. So now that I've gone through all that, I'm going to now start going through the Q&A. I know we already have some questions in there. Feel free to put in more if you think of any. So one person asked, how will time of use rates impact your net metering and your solar cost of your solar system? So if you have time of use in your area, I would recommend looking at how solar is looked at in California, where their net metering system is entirely based on the time of use and when you are exporting power to the utility grid. The short answer, however, is that having a battery can allow you to take more advantage of time of use by importing power from your battery into your home when the power from the grid is more expensive, and taking power from the grid when the power is cheaper. So it can allow you, depending on the battery you get, you can actually program it to do that automatically. Hopefully that answered your question. As I said, California uses a similar system to our time of use in certain areas, so I'd recommend looking there, but feel free to ask further questions in the Q&A if I prompted any more questions for you. The next question is, does installing the panels on the roof reduce the life of the roof at all? This participant is in the process of closing on a house. Congratulations, that's really exciting, and I agree, you definitely don't want to ruin your roof or do anything that might manage a roof that was recently replaced. Adding solar does not damage the roof at all. It is resealed, and anywhere they have to put a hole in the roof in order to mount the panels. It depends a little bit on the structure of your roof, how that is done. If you have a shingle roof, they might need to put a hole in, but they will ensure that there are no leaks or anything that would further damage your roof or lower the lifespan of your roof. If you have a metal standing seam roof, there would be no holes. There is actually special racking material that will clip on to the seams of a standing seam roof using tension in order to really ensure that your roof is not being damaged. But either way, your roof it will not lower the lifespan of your roof. However, it can limit some warranties that might be on your roof. So that would be a great thing to check on in the paperwork about your roof or with your solar contractor. The next question is with regards to Energy Trust rebates. If the solar system was standalone, not on a grid, therefore not registered on the PG&E bill, do the rebates/incentives still apply? I believe you can still receive the Energy Trust of Oregon rebates for getting solar, even if it is not a grid-tied system. However, I am not 100% confident on that, and if you send an email to our email address, great, that is now pictured on the screen. I'll be happy to do some research and double check that with my contact at Energy Trust of Oregon in order to make sure and get you a good answer. The contact email is info@solaroregon.org. The next question was, do the panels ever need to be replaced, and how long is their typical service life? Solar panels have a warranty of 15 to 20 years, depending on the panel you receive. And technically, that is the life of the panel as on the box. They expect it and will guarantee that it will work for that length of time. However, I know of systems that are 25 to 30 years old that are still working at 80% efficiency as the day they were installed. So they will go out eventually, as with any piece of technology. However, we are seeing that they are lasting much longer than anyone previously expected. You will see some reduction in their productivity. However, that is usually within 10 to 20% at max within the first 25 to 30 years from all the research I've seen on it. Another person asked, what is the useful life of a battery? Similarly, batteries have a warranty of about 10 to 15 years. However, they are a much newer piece of technology, and how long they last is not quite as well known. We're still figuring out how long older batteries are remaining operational for. As far as I'm aware, I think they die out a little bit quicker than solar panels do on average. However, they are guaranteed to last or can be replaced for the lifetime of their warranty at minimum. Really quickly, before I answer the next question, I am going to launch one final poll. This is just about how I did as your presenter in making sure we're covering the things that our funders want us to cover. So if you wouldn't mind, please fill that out. I'd be very appreciative. The next question is it better to lease a system? Leasing systems is not very common here in Oregon. It's more common in other parts of the state that have different net metering systems than our one-to-one. If you are leasing a system, be sure to read all the contracts very carefully to ensure you are not at fault if for any reason you decide to move and do not want to continue with the lease. I've heard some horror stories where because someone is moving and therefore not going to have solar anymore, that they are stuck in a contract they have to pay out, and it can get very messy very quickly. Solar leasing is an option. However, in most cases, it doesn't actually change the way your power system works, as you are basically renting your solar system, your roof space to a leasing company to generate power. You would still be paying a similar bill. However, instead of to your power company, whether that's Pac Power, PGE, or someone else, you're then paying it to the lease. They are great. They are an option. However, we typically do not see them in Oregon, as I said. I'm more than happy to stay on and answer any other questions people have. If anyone needs to get going, I know it's a little bit earlier than this presentation is scheduled for, but you can get an extra 30 minutes back in your evening. But I am happy to stay online for however long people would like if there are more questions. Thank you so much, everyone, for coming today. I really enjoyed getting to talk about solar and storage with you.